going to do an example here from the book on the expected value problems, the applications here of our mean of our probability distribution. I'm going to do 29, this expected value for life insurance. And we're told there is a 99.86 probability that a randomly selected 30-year-old male lives through the year. And based on U.S. Department of Health and Human Services, and this makes sense for us, right? It's a pretty good probability that a random 30-year-old male lives through the year. Fidelity Life Insurance Company charges $161 for ensuring that the male will live through the year. If he doesn't survive the year, they pay out $100,000. So from the perspective of this 30-year-old male, what are the monetary values corresponding to the two events of surviving and not surviving? Well, if he survives the year, he's out $161 for being insured. Now, if he dies, what does his family get? Well, his family gets $99,839. In other words, they get the $100,000 minus the $161 that he paid in. And then we were given values for this, right? This was 0.9986. That's right there, given that was the probability that he just loses the $161. But if he dies, what's then the value? Well, 1 minus B2, so this 0.0014, that's the probability. So you can see here that we have then a probability distribution. This equals 1. We have values associated with each one. Now, it's a small one, but it's a probability distribution. So these are our two monetary values, okay? So surviving, negative 161, not surviving, this 99,000. Now, what is his expected value? So this is the mean, right? This is the formula for mean, x times p of x. So in this case, I'm going to do that. I'm going to do A2 times B2, okay? And I'm going to fill down. Then the formula says I sum them. So I'm going to add them all up. And right there is my expected value, negative $21. So this means that on average, he can expect to lose $21. And that takes into account that obviously some 30-year-old male will die. But this means that the life insurance company, for C, will expect to make a profit. Because yes, well, they might have to pay out one or two. They're going to make all these 161s. It's going to even out. And they're going to come out $21 ahead. Each male approximately loses $21 on every one, factoring in the one or two who die. So you can see this is kind of a real life version of what we're doing with these probability distributions. And obviously this is a small one, but you can see this being expanded. But this is how these are figured out. This is how life insurance companies decide on how much they have to charge you so that they make a profit while still hopefully being competitive with others.